When you are into programming, you got to know the fundamentals really well. If you know the programming fundamentals well, then irrespective of the programming languages that you'll be learning and working on, your work will be much easier. Because some of these fundamentals remain almost same across programming languages. So you learn once and you reuse across multiple programming languages. You also will be encouraged to work on multiple programming languages with ease. Hey, today we are going to talk about one such programming concept. If you learn that well, if you know that well, building software, building applications would be much easier for you. In this video, we are going to learn about APIs. I hope you enjoy it. This is a beginner friendly video to cover a lot of things about API at the ground level. But if you are already experienced with API and you have a lot of knowledge about it, you can still go through this and feel free to share your knowledge in the comment section below. Alright, so without any further delay, let us get started and start knowing what are the things we are going to cover in this video. We are going to cover a lot of cool stuff. First, we'll understand what is an API and why to use it. Then we'll look into where APIs are different. Are all the APIs the same or there are differences in them? Then we'll talk about API layers. We'll see a lot of examples of APIs. We'll see different types of APIs that we can use and develop. After that, we will do the anatomy of API, where we will be looking into much more details of an API. And finally, we'll end it with different API architectures. So the first thing first, let us get started with what is an API and why we should use it. In most cases, a software is not just one module or one program that you will be running. A software might have multiple programs, might have multiple sub-applications within it. You have to make sure that all those programs, sub-programs, and the applications come together to get you the final output that you are looking for. When there are multiple modules, when there are multiple sub-programs or the sub-applications, those modules or the sub-applications or the programs need to talk to each other. They have to pass data from one to each other. They might have to get data from one and then pass it to another one. So this talking, this communication has to be done in certain ways. There should not be some random ways that each of these modules are going to talk to each other. We have to establish some amount of standards or protocol using which these modules can talk to each other. API is exactly going to do that particular job. API, whose full form is Application Programming Interface, is the set of rules or the protocols that the software modules or the programs uses to talk to each other, to communicate with each other in whatever the way that we would like to. Now, it might happen that within one software, there are multiple modules that want to communicate with each other, or it could be there are multiple software system itself want to communicate with each other. In both the cases, APIs plays a very big role. As we now know, like what exactly API at a very high level, we have to get into that mindset of what exactly we call API. Can we recognize something as an API? Can we see API in the software programming system as we can see a particular database or a UI? Can we recognize an API? Are there only one type of API? Let's see that. At times, we start generalizing the term API. Application Programming Interface, as we just spoke, are kind of rules and protocols through which the softwares will communicate with each other or the submodules will communicate with each other, but there are different varieties of API that exist. When you say something API, as a beginner, you might have all the options to get confused like what exactly we are talking about as an API. So let us now look into how does that API gets formed and how those might be different. Are APIs are something which can be called only using HTTP or HTTPS protocol, or there are other ways that API can be called. In software engineering, two modules or even two softwares can talk to each other with various protocol. It is not necessarily that they will be talking to each other only over HTTP or HTTPS. There could be simple functions that you can call and get something out of it. For example, if you are aware of the entire NPM ecosystem, there might be a library that you install using NPM, and that particular library might provide some of the functions or expose some of the functions that you want to use in your application to get your job done. Those functions are also can be APIs. You don't call those functions on HTTP. Rather, you install that library locally and then invoke those functions wherever you feel appropriate. On the other side, there could be something which is available somewhere remote, somewhere outside, somewhere on the network, and you have call over the network using a protocol, let's say HTTP, and if you want it to be unsecured, let's say HTTPS, and want to get the data into your system and want to work on it, in that case, the API will work on HTTP. So it is not absolutely correct to assume that when you are making the API calls, it is always going to be over HTTP, and you always have to form a URL to get your API call done. API call can be done quite locally. It can be just function calls. When we talk about the API architecture towards the end of this video, we are going to talk through different kind of APIs and the norms exist, and based on that, your APIs would look entirely different when you try to consume them or want to build them. When we talk about APIs, we have to understand the client-server architecture a bit, or a provider-consumer architecture a bit. Provider or the server are the facts that going to provide you the functionalities through APIs. The consumers or the client are the facts that are going to consume that API and want to get their work done. Here on the screen, we are seeing a client and a server. A server, let's assume a movie server, which can provide the details about any movies that you are searching for. On the client, you are seeing a laptop. It could be a mobile, a particular browser, where you have an application where is a search bar. There you are typing a movie name, for example, Spider-Man, and you are requesting the details of that particular movie from the movie server. Now, this particular request can happen using API. On the movie server, you have the movie data. On top of movie data, there can be APIs available that from the client side you can invoke and then get the data and can show onto your UI. Here, the request and response that you see, it is something that client requests certain thing using the API from the server, and as a response, you get the data back so that you can work with it. When you get into API anatomy, I'm going to explain a lot more about this request response that takes place in terms of API handling and the API calls. This is probably a most clear analogy that somebody can think of in terms of APIs, and I'm sure that in many places this analogy been used. Think of API client and the server entire infrastructure like a restaurant or the hotel. Somewhere in the restaurant, in some room, cooks are cooking the food for you. You as a client come to the restaurant, sit on the chair, and then look into the menu, and then you order something that you want to eat. And this order is placed through a waiter in that particular restaurant or the hotel. What that waiter will do, the waiter will go to the kitchen, will tell the cook, hey, this is the order that this particular client has placed. Why don't you make it ready? While the cook is making this particular order ready or the food ready, the waiter is not going to wait there. The waiter is going to go to the other table, going to take the new order, again come back to the kitchen, again placing the order to the cook, asking them to cook. As and when the cook is making the order ready for a particular table, the waiter will be taking the food in the hand and then will be serving that to the appropriate client on their table. Now, this particular analogy fits really well with APIs. In case of API also, the client, which can be your browser again, which can be any connected system, can be a mobile, can be a laptop, whatever, right? On network, request something to the server. What API does, API takes that request to the server, and then once that particular response is ready from the server, the API gets back to the client with that response, and the client uses that response to get something meaningful done. So I hope this particular analogy makes sense to you and it will help you to remember APIs quite well. Taking the previous example and the analogy forward, here the clients are the handheld devices like the laptop and a mobile. And then at the back, you have data store like a database or a file store. And you also have an application server. And in front of that, you have APIs. Now, let's say that your user details are stored in this particular database, and there are certain things stored in the file store as well. Now, from your client, if you need to get a particular data from a database or a particular information from the file store, it can be served pretty well through APIs. You can call the API. The API will have the knowledge of the server through which it can get to the data. And once the data is fetched with all other authentication authorizations system in place, then the data will be back through API responses to the client. Here I want to mention that just like this video, the APIs, if you want to understand authentication authorizations as another fundamentals, I have created a video. You can check that out. The link to that video is in the description of this video. So I hope at a high level where API places itself and how API helps you to communicate between two different software systems or within a software system, two different parts or two different modules quite easily. With all the understanding so far and how we call this API as application programming interfaces, let us look into different layers of API. API, which is application programming interface. So what is application here? What is programming here? And what is this interface mean? I'm sure that by this time, as you already got a good amount of heads up about each of these pieces, is the time that we can join them together and the definition of an API can be really fulfilled. The A part, the application of an API, can be any software that runs on your mobile, web, desktop, any IoT devices, can be any application in this world. P, the programming part where the core logic lies. The logic can be written with any programming language like Java, JavaScript, Go, Python, C, doesn't matter, any programming language. And the I, the interface part, is for applications, the software applications to communicate. What we just explained, like in the beginning, that if there are software applications or the modules, sub-modules, they want to communicate with each other, we need certain amount of protocol or the rules for them to communicate. API provides that. Now, those rules cannot be standalone. For those rules to be applicable, we have to understand that how those rules are developed, how those rules are built. For that, there is a need of programming language. You also need to understand that what kind of applications we are dealing with. This communication is required between two applications. What are those two applications? Are we talking about two software applications, or we are talking about a software application is going to talk to a sensor at the back of it because it is an IoT application. So each part of API, be it application, programming or interface, has to be designed quite well. So I hope the definition of API is quite clear now. As we understand the definition, as we understand the working of it a bit, let us now look into a few examples. We have also spoken about that APIs are not all the same. It means that all the APIs, you cannot say all APIs are going to be same. Their construct can be different. They can deal with things differently. So let us look into some of these examples and then get little deeper of them to understand how they are different. On your screen, you are seeing a different varieties of APIs. The first one, which says https api.ipstack.com/some value. This is an API that provide you the visitors on your website by their IP address, the details of the visitors basically. So this is an API that is available for you to consume. But notice this API has a construct of an URL. It has a protocol called HTTPS, then the particular URL address and followed by more subpath of that URL. Like this one, there is another one which can fetch the information about worldwide holidays. But look at the third one. The third one doesn't have any HTTP or HTTPS in it. It looks like this is something like a package or a library that you are using to instantiate something, and then on top of that you are calling an API called search with certain parameters. As I was explaining in the beginning of it, that each of the APIs and their construct could be different. Here is an example that this particular API, it's a Java API for a job search engine, which is way different from the last two APIs and its construct that we spoke about. Again, the next API is API that runs on HTTP protocol. It gives you the real-time stock market data, whereas this one is again entirely different. This is a JavaScript web API that is available on our browser. Navigator is an object that's available by default on our browser. On that, there is something called media devices. On top of that, you can call something called get display media to get the audio video stream. This is definitely an API because it's going to provide the communication and the integration between the low level hardware system of your laptop or mobile or whatever to the high level applications where you will be accessing those camera or the audio. Whereas each of this over network can fetch you the data about certain things A thing like navigator.mediadevices.getDisplayMedia helps you to interact with your hardware devices over an API call and get you the details that you want to work with. Similarly, the next one is again over HTTP, gives you the weather data, whereas the last one might be more useful for an IoT system, Internet of Things system, where you want to use the Google Assistant to get something done. So I hope these examples also helps you to understand that how APIs can be differentiated, what are the things that you should be calling APIs, and their construct is also could be different. So you know that the API construct can be different, but are there different types? What are the different types of API that exist? APIs could be both private and public. The APIs that are available for the public consumptions, it means that to call those API, you might need an API key to provide to get the information by calling those API, and it is publicly available, means anybody can call them. That information is not guarded, that information is not hidden from the public at all. You can just make the call whether over HTTP or using the method, using the functions, different kind of APIs that we have seen so far. But the main thing is like those are publicly available for you. Private APIs are mostly for the enterprises where a company decide to create an API for their applications, and then application is probably they are selling to their customers, but not necessarily the application which uses the API to get the data from their database system or the data store. They want to make it public. They don't want to make it public, they want to keep it private. Apart from selling their applications, they might want to sell the API also as a service. They want to price the APIs and they want to give the APIs to their end customer so that the end customer can consume the API and can build their own user interfaces and own use cases. That is also possible. Some point of time, there might be a middle path between private and public APIs. There could be possibilities that two organizations want to talk to each other and then they want to share some APIs between them. High level APIs are of two types, private and public. Let us now look into the anatomy of an API, and here we'll be taking a case where you are making use of this API over HTTP, the most common use case of APIs. Let us look into each of the factors that are involved for calling an API, getting the details by calling an API, and how to handle them step by step. You have seen this on your screen some time back, isn't it? You had a client, you had a server, client is requesting something, and the server is sending back the response. The request and response is being handled using an API call. But now let's zoom in and deep dive. So this API client will start the communication sending a request to the application server or the API server. Now this request can be sent from the client in many ways. For example, your application might have a button that user click on it and then you can send a request to the server, or there could be a search bar, you can do that, or maybe you want your user to paginate from one page to another page by going next or previous, and through which you want to make an API request to the API server. So client makes an API request to the API server. Now when we talk about request, there are multiple things that gets involved in the request. As we are talking about this API call over HTTP, we have to understand a particular term called API endpoint. A API endpoint is part of a URL that provides access to some resources that are there on your server. So for example, if your server has user data and you want to get access to user data from your client through API, you should have an API endpoint call /users to get the information about your users that are there on your server. As simple as that. As we are talking about the API calls over network using HTTP protocol, there is another thing also you need to keep in mind, which is called method. The primary methods for the CRUD operations, which is like create, read, update, delete, are for create it is post, for read it is get, for update it is put or patch, and for delete it is delete. So you got to make sure that you understand these HTTP methods before you start using APIs, because you might want to get all the users, so you have to use get call. You might want to create a user, you have to use the post method. If you want to update the user's data, you have to use the put. If you want to update a particular details of a user data, you have to use patch. If you want to delete a user, you have to use the delete method. And all this thing will happen on the API endpoint called /users, because you are dealing with the user resource that resides on your API server. That's how things are connected. On top of this, when you are making the API request, you can also put certain request headers. For example, you can have authentication authorization header. For example, if you want to create a user, you might have to tell to your server who is that legitimate client who can create an user on the server. For that, you have to pass the authentication credential or the authorization header. Again, if you're new to authentication authorization, I have a video created. Please take a look at that. And along with the request, at times you also have to pass something called request body. What is the request body? When you want to create a user, again, taking this example, you have to tell your server that user will be created with this particular username. Maybe the user's password is this, user's email is this. So certain user information that you have to pass from your client to the server. This particular information that you will be passing from your client to the server has a name which is called payload or the request body. So request will also have something called body apart from header or the payload that you have to pass from the client to the server depending on what kind of method that you're dealing with. For post and for put or patch, definitely you will be passing certain payload, because with post you'll be creating certain things on the server. For put or patch, you will be updating certain data on the server. Hence, header and the body is something that you need to remember. All right. So once the request is received through API to the server, server will be responsible for first check if there is authentication available, who is this user, whether the user is legit to perform this operation, do certain kind of validations, and then once everything is done, the data that is requested using API will be sent through this response. Just like request, response also has a few things. For example, response will definitely have a header through which you can tell client a few information about the server. Response also will have a response body. For example, if you do a get call, you want to get the details of a user. Through response, you will get the details of that particular user you're requesting for, isn't it? So your response will also have header and body. Apart from header and body, response have something called a status code. Again, something very important. When a successful operation happen, the success factor of an operation usually denoted by a status code called 200 or OK. If something successfully fetched is 200 and OK. If something successfully created, for example, the status code that the server will send will be 201 created. Like this, there are different series of status code available. The series that starts with 2 are usually the positive status code that says that something is good in your system, something successfully happened. Then again, if something starts with 4, which is not so good, for example 401, there is some problem with authentication. If you get 404, that means your page not found. Similarly, if something starts with 5, again it's not a good news. A 500 could mean that there is a server error. So depending on what kind of response code that your server is sending to the client, you would know because of what is the state of your API request that you have sent from your client earlier, and based on that you have to take an action. For example, if it is OK or created, you successfully show the message that everything is great, but if there are error, you have to handle those error on the client side. Now, all this error handling, all this making calls, every of these situations are something that we'll be doing day in, day out in our coding. But before we take that step, it is very important to understand some of these fundamentals that we are talking right now, like what is placed where, why certain things are happening, and why there is a response code, why there is a method, what is this endpoint, where is the server, where is the client. That's why we spend some time doing this anatomy. There are different API architectures possible. Let us now look into the different API architectures and try to understand what are the difference between them at a high level. Each of these API architecture that I am going to talk through demands an individual video, and I'm going to make them to explain like how you can develop each of those architecture and create the API services for your customers. But that's in the subsequent videos. Right now, at a high level, try to understand what are those architectures are about. Here are some popular API architectures available. For example, SOAP, REST, GraphQL, grpc, webhook. So let's start with SOAP. When I started my career way back, API architecture that I worked with was SOAP, which is like pre-era of REST architecture. The SOAP stands for Simple Object Access Protocol. Simple Object Access Protocol. Primarily, it uses XML to transfer the messages between a client and the server. That's how it works. It uses XML to transfer the messages between client and the server. So it will be the responsibility of either of the cases to parse that XML, get the data out. The SOAP API structure is not being used too much in the recent days, but you will definitely find systems which have used SOAP infrastructure may not have migrated to something like REST or GraphQL recently. So it will be good to know in depth like what SOAP does. I may not make a video on SOAP, but when I make a video on REST and try to create the REST APIs, I would definitely take a differentiation between SOAP and REST. Moving over to REST. This is undoubtedly one of the most popular API architecture available, and it's there for last several years, and people are using it to create those CRUD operations, the create, read, update, and delete. And it works on HTTP. It works on the HTTP methods such as get, post, put, delete. Just now we have seen like how those get, post, put, delete get mapped to each of those operations. This is primarily being used for transferring the data or fetching the data over the internet, over network. And here you have a concept of resources. And then for the resources, you have to define endpoints. And for those endpoints, you have methods like get, post, put, delete that your client will be using to transfer or deal with the data. Stay tuned. I'll be creating a video where we'll be using Node.js and Express to build the RESTful services, and we'll see like how to access them from the client applications as well. Next comes GraphQL. This is an open source query language, very, very different from REST from the architecture point of view, where REST can have multiple endpoints. For example, there can be something for users, could be for to-dos, could be for online users, but GraphQL is always about one endpoint, and it is completely driven by the queries, where using the queries you can combine different nodes of the graphs and then fetch the data that you absolutely needed. GraphQL is much friendlier in terms of fetching the data for your use cases on your application than REST. Then comes grpc. It is by Google. From computer science, the full form of RPC is remote procedure call. It's yet another API architecture that you can use for your client to call the server in a way that it might feel like the client is calling any kind of local object. This is mostly used for the distributed applications for the systems to communicate with each other. The last is the webhooks. In this API architecture, you can implement mostly the event-driven system. A typical use case of webhook could be, let's say, once a particular account subscribe to your newsletter. Now the application can send a HTTP request to a webhook URL with all the event data, the subscription data, and all the payload possible, so that this can be utilized further for doing any further operations, right? So I hope this API architecture at a very high level is clear to you. SOAP, REST, GraphQL, gRPC, and webhooks. I hope you learned something new. I'll be so happy if you can let me know with a comment or if you like this video. Up next, I'm going to get through a lot more programming fundamentals like this, which can teach you things in a beginner friendly way. And if you don't want to miss out, please subscribe to tapaScript, because it gives me a lot of motivation to bring a content like this in front of you. Check out all other playlists that are available on this channel, and I hope you learn from them as well. All right, see you soon.